we will talk about adding fractions. Okay. Adding fractions or subtracting fractions are actually harder than multiplication and the division of two fractions. You will see why. Okay. Let's start with the easy case. Add two fractions with the same denominator. You see right here 1/5 plus 2/5. Here you have 5 blocks, and 1/5 is like 1 out of 5 blocks. 2/5 is like 2 blocks out of 5 blocks. Then you know when you do addition, you basically do is add those boxes. So you have 3 boxes out of 5. So that would be basically 1 plus 2, which is 3. That's 3/5. Final answer. So adding the fractions with the same denominator is a very easy case. The problem happens is that if denominators are different. Now, this one involves multiplication of fractions. So we need to review that. Now, what is the result for 3/4 times 2/5? Look, 3/4, let's say we have 1, 2, 3, 4 units. Then 3/4 is basically 1, 2, 3 out of 4. 2/5, 2 units out of 5. Then, you know, if you want to find out the area of this shaded part, it's this length times this length. So it's basically 3/4 times 2/5. Okay? Then you can see how many boxes do we have. 1, 2, 3 times 2. So we have 1, 2, 3, 4, 5, 6 boxes. Okay? Now, 6 boxes out of how many boxes? The total is 20. You see 1, 2, 3, 4, 1, 2, 3, 4, 5. So 4 times 5, we have in total 20 boxes. So basically the answer is 6 over 20. Okay, 6 20s. All right. So the answer here is correct. But you know, this can be reduced. We will talk about this a little bit later. Anyway, from here we get is that one fraction times another is numerator times numerator, denominators times denominator. Okay? So you see 3 times 2 is 6, 4 times 5 is 20. Now from here we can derive a very confusing property. Look, A over B is actually equals A over B times 1, because 1 times anything is that thing. 1 is C divided by C. C can be what? C can be 2, 2, so 2 divided by 2. C can be 3, 3 divided by 3 is still 1. So C can be anything. Okay? So A over B times C over C, by the definition of the multiplication, should be A times C, AC, over B times C as BC. Okay? So this one, AC over BC, equals A over B. That means if you see C here, you can basically drop this C and go back. So we call from this direction, from here to here, is called cancellation. Cancel C above, and below. Cancel those two c's. Now you know right here, we'll do it later. Look, 3/10 is actually equals 3 times 2 over 10 times 2. So you see 2 can be cancelled, you have a 3/10, right? The same thing right here. So C in this case is 2. Okay? Okay, so 3 times 2 is 6, 10 times 2 is 20. Then you can see 6/20 is actually 3/10. Okay, we saw just now 6/20 is actually 3/10. So those two are equal. Okay, those two are equal. Now, you cannot reduce 3/10 anymore because there is no common factor. 2 was common factor here. But here, no more common factor between 3 and 10. So 3/10 would be called lowest 10. Okay. Now, for the addition or subtraction of numerators, you need to go from this direction to this direction. So that's why, you know, one we call it cancellation. Another I wrote is needed for addition or subtraction about fractions. Let's see why this one is needed from here to here. Now we look at 5/6 plus 7/10. You know, 5/6 equals 5 times 5/6/5. Because you cancel those 5, it goes back. 5/6. Same thing happened for 7/10. Because 3 can be cancelled. Okay? Now, the reason I do this is that 6 times 5, you have a 30. 10 times 3, you also have a 30. Of course, upscale 5 times 5, you have a 25. 7 times 3, you have a 21. Okay? The reason I do 5 times 6 get 30, 10 times 3 get 30 is because in this case I make two fractions. Denominators are the same. I make those two denominators be the same. You see that? 30, 30. Now, as long as they are the same, then you can add. You can add. You add is what? 25 plus 21, that's 46. Okay? 46/30. 46/30, there is a common factor 2 here. Okay? 46 can be divided by 2, 30 can be divided by 2. So 46 divided by 2, you have a 23. 30 divided by 2, you have 15. Alright? So in this case, you reduced this fraction to 23/15, and this is the lowest 10. You may say 23/20, 23/15, numerators are bigger than denominators. Fine, I accept this answer. Okay? It is called improper fractions, but it is fine for me to take it. All right. Now, let's look at the following way. 5/6 added by 7/10. You see, you can also do is that 6 multiplied by 10, 5 multiplied by 10, again 5 times 10/6 times 10, 10 can be cancelled, it goes back to 5/6. And here 10 can be multiplied by 6. So 10 multiplied by 6, 7 multiplied by 6. Okay? The reason I do this again is that 6 times 10 you have a 60. 10 times 6 you have a 60 again. So you made those two denominators are the same. Then you can add numerators. As long as you see denominators are the same, you only need to add numerators. You don't add denominators. Okay? So 50 plus 42, you have a 92. Okay? 92 over 60. Then this one can be reduced. 92 over 60, you see 60 can be divided by 4. You have a 15. Okay? And then let's see, right here, you have a 92 divided by 4, that's 23. Okay? That's 23. So you can see here we did 5 over 6. You do is 5 times 5, 6 times 5. So you go is what? You go is from 5 over 6, from this part, left-hand side, goes to the right-hand side. So that would be what? That's what I wrote here, needed for addition among fractions. Okay, you make A over B times a common factor. The reason you want to do is you want to make denominators are the same. Denominators be the same. So that's why you can see here the multiplication of fractions are involved when we do additions. So additions of fractions is harder than multiplications. Okay? So you do like 2 directions, from here to the right-hand side. As long as you reached final answer here, almost the final answer, you need to reduce it. So then you do is from this direction goes back, because you see right here, there is a common factor 2, 2 here. So you need to do is delete, cancel that 2, it goes back here. So actually addition right here, you do 2 directions. One is from the left to the right, and the final answer needs to be reduced. Okay? So you then get that. So that's why I said it's more complicated for addition. Those 2 ways work, both work. Previously you have a 30, and then this one you have a 60. So denominators here are 60, here are 30. So 30 would be the smallest. So 30 is the least common denominator. Of course, you can make denominator, common denominator be 120, I believe. Okay? 120 for sure right here. But 120 is bigger than 60, is also bigger than 30. 30 is the least common denominator, which is called LCD. So when you do addition or subtractions, you need to find LCD, least common denominator. Okay? Least, smallest, common, the same, 60, 60 denominator. All right? Now, let's work on that. More examples. We'll look at this example and then this example. The first one, 3/4 plus 1/12 minus 1/6. Okay? So, how do you find out the common denominators among 4, 12, 6? This is the way book does. This is the way the book does. You write 4, 12, 6 here, 4, 12, 6 here. Every number can be divided by 2. So you put 2 here, and then 4 divided by 2, you have a 2. 12 divided by 2, you have a 6. 6 divided by 2, you have a 3. So you put all your quotient downstairs below the dividend. Okay? Okay. Now, then you see 2, 3, 6. 2 and 6 can be divided by 2. So then you put the quotient right here. Okay, put quotient right here. 2 divided by this divisor, then you have a 1. 6 divided by the divisor 2, so you have a quotient 3. 3 cannot be divided by 2. Move it down. Copy it. Okay, 3, 3, copy it. Now you have a 1, 3, 3. 3, 3 can be divided by 3. So you put 3 here. 3 divided by 3, the quotient is down here. 3 divided by 3, the quotient is down here. 1 cannot be divided by 3. Move it down directly, as we did right here. Now you have all the border numbers, the boundary numbers. Multiply all of them together, you will get your LCD. Okay? So you can see right here, LCD, 2 times 2 times 3 times 1 times 1 times 1, that's 12. So 12 will be your LCD, least common denominator. Okay? Now you know you want to make all the denominators be 12. From 4 to 12, you need 3, because 3 times 4 is 12. Then you have a 3 times 3, 4 times 3. Okay? So you made downstairs be 12, upstairs be 9. This one is already 12, so you don't need to do anything. Raise 6 to 12, you need 2, because 2 times 6 is 12. So then numerator, denominator multiplied by 2. Alright? So 1 times 2, you have a 2 here. That's 2 over 12. Now you have all the denominators are the same. Then you do is add or subtract numerators. 9 plus 1 is 10 minus 2, which is 8. 8 over 12. You need to reduce this one to the lowest 10. Because 8 can be divided by 4, which is 2. 12 can be divided by 4, you have a 3. So the final answer is 2/3. Now, let's look at another example here. Step 1, find LCD. Now, 35, 10, 14, you want to write in this way. Then 7 divides at least 2 numbers. 35 can be divided by 7. 5 is the quotient, because 5 times 7 is 35. 10 cannot be divided by 7. Take it down directly. 14 can be divided by 7. Then you have a 2. 2 times 7 is 14. Now you have a 5, 10, 2. Okay, you can put 5 here, 2 here. 2 divides 10 and 2. So then you have 2 times 5, which is 10. 2 times 1, which is 2. 5 cannot be divided by 2, so you copy 5 down here. Okay? Now, 5, 5, 1. Of course, 5 divides this 5 and this 5. You put a quotient here. 5 divided by 5, that's 1. 5 divided by this 5, that's another 1. 1 cannot be divided by 5 exactly, so put 1 here. Then again, the LCD would be the multiplication of boundary numbers. 2, 7, 2, 5, 1, 1, 1. 7, 2, 5, 1, 1, 1. Together is 70. So 70 would be your LCD. Now you need to raise 35 to 70. You know 70 divided by 35 is 2, so then you know 2 will be the number you want. Because 2 times 35, you have a 70. Okay? Then 8 times 2, then you have a 16 here. You want to raise this 10 to 70. 70 divided by 10 is 7. So you know you have a 7 right here. Okay? So 10 times 7 is 70. 6 times 7 is 42. And then 14, you want to raise 14 to 70. 70 divided by 14, you have a 5 there. So you know you need 5 here for both numerator and denominator. 5 times 14 is 70. 5 times 5 is 25. So then you have a 16 plus 42 minus 25, which is 33. Okay? 33 over 70 is our final answer. Okay, and then those two examples are a little bit complicated. You need to find out the similar questions in your book. Okay, follow those steps to find out LCD and do some questions like that. Okay. And good luck with those exercises. I'll see you next time.